Hi guys, it's Mr. Jenkins. This will be your next lesson in chapter 4. Starting right now though, 4-6 kind of through 4-9 is going to be covered as a different unit. Okay, so we'll be talking about completing the square here. This is another way to kind of factor. But now we start to focus on how to factor those kind of unfactorable problems. All right. As always, on these notes, they're kind of nice for people who like these step-by-step kind of deals. This kind of shows you the process. So, anyways, that'll be completing the square. Okay, so actually before this, we're going to solve by square roots. All right, so this would be, and again, in this lesson, we are just solving algebraically. I'm not going to pull up a calculator or Desmos. Okay, just solve algebraically. All right, so in all these, if we look at these problems, 4x squared plus 10 equals 46, all the way down to 3x squared minus 96 equals 0. There is no bx term. All right, so if there is no middle term, no bx term, these are really the easiest ones to solve. All right, so all we need to do, and we had a problem similar to this on the test, all we would need to do is, like it says, isolate the x squared. So in A1, that would be move over the plus 10, so that would give me 4x squared equals 46 minus 10 is 36. Then I'd want to kind of go ahead and divide both sides by 4, and that's going to give me x squared equals 9. And then at that point, I am ready to, kind of undo the square part. So I am taking the square root of both sides, technically. But here's the part that you'll tend to forget, right? Remember, there's a positive and negative real root there. So it's x equals plus or minus the square root of 9, right? And then we kind of just need to simplify the radical, which we'll work on that probably on our DMR. So that gives me x is equal to plus or minus 3. All right, so I want to do another one where we don't get such a clean answer. Let's maybe look at A4. All right, so A4, move over the minus 96. That's going to give me 3x squared equals 96. Divide by 3, and we get x squared equals 32. So 32 obviously is not a perfect square, so we're going to get a weird answer when we take the square root. So we get x equals plus or minus whatever the square root of 32 is. Sorry, I put 36. Thinking about a perfect square, I guess. So square root of 32. And then, like I said, we will work on this skill, more on the DMR. But the square root of 32 simplifies to, don't forget your plus or minus. That would be 4 square roots of 2. All right. So the reason is because you can break it down into the square root of 16 times the square root of 2. Okay. All right, so moving on. Looking at these types of problems here. So this is what, now we'll get to the kind of the meat and potatoes of the lesson, if you will. This is kind of what we want to accomplish when we do complete the square. We want to get our equation to kind of look like this. All right, so I'm going to skip B1 and go kind of to B2. So if we had this equation, what would we do? We would, we could take the square root of both sides, right? And that would give me, in this case, x minus 8 equals plus or minus, no, don't ever forget that, the square root of 20. All right, so then we could move over the minus 8. So it would give me x minus 8 equals, sorry, try that again. Forgot what I was doing, I guess. gives me x equals 8 plus or minus the square root of 20. And then you want to try to simplify that as best you can. So the square root of 20 is going to simplify to 2 square roots of 5. So final answer, let's just put an equal sign there. X is equal to 8 plus or minus 2 square roots of 5. Now be careful there because you'll be tempted to add the 8 and the 2 and make that 10 plus or minus the square root of 5. But that is not correct. This 2 times the square root of 5, 2 is almost like a coefficient, like it's attached to the 5, okay? All right, so let's do one all the way through, right? So looking at B3 and B4, you know, what we need to do is basically we want to get it to the form that it's in B2, okay? So let's go ahead and do that. All right, so this is what we have there is a perfect square trinomial. Okay, that's a perfect square trinomial. So it's going to factor out to a minus b squared. Okay, a minus b squared. And that's what you want in all of these. They're all going to be kind of perfect square trinomials. That's the point of complete the square. So anyways, so a would be x, b would be 7. So we're going to rewrite this side as x minus 7 squared equals 25. And then from there, now we have it in this form, so we go ahead and repeat that same process. All right, square root both sides gives me x minus 7 equals plus or minus 5. Move over the minus 7, x equals 7 plus or minus 5. And then you would need to simplify this because you can, right? Because 7 and 5 are like terms. So that would simplify to x equals 7 plus 5 is 12. 7 minus 5 is 2. So 12 and 2. All right, I'll let you look at B4. Okay, it's got more of a complicated kind of answer. All right, so I suggest you look that up on the notes. But I do want to spend most of the time on this video looking at not Algebra 1's DMR, but what your kind of test questions might look like. So I'm going to scroll down to example C, where we kind of complete the square, and then we'll go all the way through an example, starting with example C5. All right, so it says we complete the square with, says given a polynomial x squared plus bx, then this term right here completes the square. So b divided by 2 squared. That is the term that completes the square. All right, so that's all we're doing here. On a test, this question would look like this. It'd say which term completes the square? X squared plus 10x, and then blank. Okay, so what term would go last? So again, you just want to do b over 2. So 10 over 2, which is 5, and square it. All right, so that would be 25. So the answer here is that 25 completes the square. Right, because why? Now we have a perfect square trinomial, right? Starts in a perfect square, ends in a perfect square. Middle term is 2 times a times b, okay? All right, so looking at the next one, does a minus sign make a difference? Let's see. So on this one, we'd go negative 14 over 2 squared. So that's negative 7 squared would be positive 49. So that minus sign does not make a difference. It's always going to end in plus something. As if it didn't, it wouldn't be a perfect square. Okay, so 49 completes the square. Looking at C4, you're just going to get a decimal there or a fraction. That's the only difference. So I'll skip those two and go to the last kind of example. I might work all 3 of these out, but I don't know, I might leave you one. All right, so we want to, on these, solve by completing the square. Okay, solve by completing the square. So first of all, why, or why would we need to? So let's ask ourselves: is there anything that's going to multiply to 2, add to -4? And the answer to that is no. Okay, so this thing does not factor. If I plugged it into Desmos or my graphing calculator, I would see that I would not have a whole number. X value solution, right? So then I would know that I could solve this by completing the square. All right, so what we want to kind of do there is let's go ahead and move the +2 over. I think that simplifies things a little. If you look at my notes, I didn't do that, so you don't have to, but I'm going to. All right, so now we want to go ahead and complete the square. All right, so just kind of looking at this part right here, looking at the left side of the equation, what completes the square? So we're thinking, what's -4 over 2 squared, and that would be +4, right? So we are going to add 4 to both sides, right? So we're going to have x squared minus 4x equals -2, except we're going to add 4 to both sides. Because what I do to one side, I have to do to the other. Okay, now on the left side, I have a perfect square trinomial, and on the right side, I have whatever I have. All right, so let's go ahead and factor the left side. That's going to be an a minus b squared. So x minus 2 squared is equal to, the other side simplifies to 2. And so now we're just solving like we would in one of the previous examples. So take the square root of both sides, gives me x minus 2 equals plus or minus the square root of 2. Can't simplify that, so let's go ahead and move over the -2, and x equals 2 plus or minus the square root of 2. All right. Just be careful with Math Excel. If they want a decimal, then you'd have to use your calculator there. What is 2 plus the square root of 2? And maybe round to the nearest hundredth or something, right? So just be careful of directions there. All right, let's just do C6, and I'll probably leave C7 for you. You may want to ask to see that in class if the notes don't make sense. Okay. All right, so looking at this one, let's go ahead and change it to x squared minus 10x equals -16. And we'll complete our square. We have half of this is -5 squared is 25. So plus 25 to both sides gives me x squared minus 10x plus 25 equals what is, I'll go ahead and write that, -16 plus 25. Okay, or you could just write 9 there, right? Go ahead and factor this side. That's going to be an a minus b squared again because of that. So that'd be x minus 5 squared is equal to 9. Now we take the square root of both sides, and we get x. All right, let that pop up here. X minus 5 is equal to plus or minus the square root of 9, aka 3. So x equals 5 plus or minus 3. And we need to obviously simplify that. So 5 plus 3 would be 8. 5 minus 3 would be 2. And obviously these answers are nicer because you can easily plug them back into the original equation. You can also see them graphically. And also another point to this is if we get answers like that, 8 and 2, what else does that tell you? That tells you that we probably could have just factored this thing out our normal way. So you might see this and think, okay, what's gonna add to give me -10, multiply to give me +16. That'd be -8, -2. So really, that would have been the easiest way to solve it, to get 8 and 2, which that's not what we're working on. So we solved by completing the square. I'll leave C7 for you guys to try, and it is in the notes. And you should always try those extra examples. They are helpful. Okay, that way you're practicing on paper and pencil, and you're practicing on Math Excel. A little bit of best of both worlds. Other than that, hope this video helps. Thanks, and have a good one.